All right, campers, welcome back. So we've started talking about project life cycles, and so now we're going to talk about different types of iterative models. So here we go. So prototyping. So prototyping is really the original idea behind iterative models. The idea is you prioritize requirements as you get them. So you always have what Scrum calls a backlog of product requirements. You refine them using customer and testing feedback until the customer accepts the product. So you build a product, you build a prototype, you refine it, you get new requirements, you build another prototype, you refine it, you build another prototype, you refine it. Eventually the customer says, I like this, and you're done. So this is a good technique for changing requirements, or if you have an application area that's poorly understood. You're not exactly sure what the customer wants, and neither is the customer, kind of thing. So here's the way this model looks, right? So you start here with an initial concept and requirements. You do a quick design. You build the prototype. You send it to the customer. The customer evaluates it. If the customer says, we're not done yet, you refine the design, go back, quick design, build a prototype, give it back to the customer. Keep doing this, dunk, dunk, dunk. Eventually, the customer says, I'm happy, at which point you do the final round of testing and then release. Piece of cake. So what prototyping does is it recognizes that it's very hard to plan the project at the beginning. You don't know what you don't know. You don't know what all the requirements are. But then if you have a small set of requirements, you can build something and you can get feedback from the customer. And it's that feedback that's the critical element here. Said that already. It's kind of risky because it's risky in the sense of you don't know when you're going to be done. So scheduling a pure prototyping thing is very hard because you don't really know. But on the other hand, it has a very good track record of actually getting code out the door. So that's one way to do incremental stuff. So pros. Improved progress visibility. Every time, typically doesn't take you as long to do a prototype as to do a final product. So every time you do a prototype, there's visibility for the user. Because you give the prototype to the user and you get feedback, then you get good input to requirements. And you also learn about what requirements have changed. Because the customer will invariably go, well, that's not what I wanted. And that's the point the requirements change. Cons. You can have an unrealistic schedule, budget, and progress expectations. The customer may think, not a problem, this will be done shortly, and it really never is. There's a possibility of bad design. So if you start with a small set of requirements and design something, and then the requirements change, you have to make the decision, am I going to throw away what I've done and refactor things to improve the design, make it simple, or do you just add on? And typically adding on is where you get a bad design. Related to bad design is the possibility of low maintainability, because what you're doing is you're doing code, then you're adding a little bit more, and then you're adding a little bit more, and it may not be a very maintainable piece of code. You may have to do lots of rework, but yes, refactoring is good. So, other types of models, what are known as lightweight or agile models. This is as opposed to the plan-driven models like the waterfall model or the early prototyping models, which require a lot of documentation, and they're known as heavyweight models. So in these lightweight models, they require less documentation and fewer process controls. Agile models are typically good for small to mid-sized projects up to 250. Actually, these days I might go up to 500,000 lines of code or so for an agile model. Above that, the size of the team gets large enough and the size of the work gets large enough that you typically have to add in some features of these more heavyweight plan-driven kinds of models. Lightweight models are good for small teams. Less than 20, I would actually say less than 10. Developers is what I consider to be a small team. I think small teams do the best job of developing software. All agile models that we'll look at, these are all iterative models. So just like what we talked about. So because Dilbert has something to say about everything, here's Dilbert's boss introducing agile modeling into their thing. Let you read that. And then I'll let you know that, by the way, that's not really how it works. It's not true that there's no planning and no documentation, but you do start writing code pretty quickly. So, back in the late 1990s, a bunch of guys, actually 17 of them, got together. In fact, late 19, I think it was around 2000, and put out what was known as the Agile Manifesto. These were guys who had done a lot of waterfall stuff, and they'd done a lot of big projects, and they said, there has to be a better way. So they got together and they came up with this manifesto, which has these 4 values: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Notice that they do not say working software instead of comprehensive documentation. They say over. The idea being that you would have documentation when you need it, but you are going to prefer to have working software, because if you do the software correctly, you can read it and that becomes your documentation. Customer collaboration over contract negotiation. Contract negotiation tends to be thought of as an adversarial idea, whereas in a software development environment, you want the customer to be a collaborator because the customer knows what they're going to want. And it's you as the developer's job to figure that out. So related to the values of the Agile models are the principles of the Agile Manifesto. There are a dozen of them. I've highlighted in blue the ones that I think are most important, which are frequent delivery of software. Every Agile model that we would look at has a fairly short iteration time, so you get software pretty quickly. Face-to-face conversation is best. That's hard to do sometimes because if the team is not co-located, you have to then either talk on the phone. You can do Skype and do video chats, and that's fine, but face-to-face is much more efficient typically. Progress is measured by working software. The idea is that at the end of the day, what you're doing is producing code. Simplicity is one of the key principles of agility, with the related idea that if you are working on a piece of code and you just think that it's too complicated, it's your obligation to simplify it and redesign the code and rewrite it. Because down the road, that will make things much better. And then self-organizing teams. There are no hierarchies in Agile models typically, and there aren't particular roles in many of these teams. The team organizes itself. Related to this and related to simplicity and frequent delivery of software is common code ownership, which is actually not on this list, and it surprises me that it's not on this list. The idea is that you don't own the code that you wrote. The team owns the code that you wrote, which means that anybody can go in and change anybody else's code. And that's a very, very important, because it relates to a lot of other things that we'll get to. So the overall Agile process looks like this. Doesn't matter what system you're using, this is what you're going to do. Okay, you get an initial set of requirements. You can use paper prototypes. You can use use cases, scenarios, user stories. There's all sorts of different techniques. But you get an initial set of what you want to do. You prioritize them. This is the team. This is not the manager. This is the team doing this work. You prioritize the requirements. Some of them are more important. This is where the customer comes in. The customer needs to be present because the customer is going to tell you what's important. You decide on which requirements the customer wants in this next iteration cycle. And typically the cycles are short, but they can vary in length. And it's the customer decides which requirements should go in the iteration cycle. The team then creates a high-level design, if necessary. They reduce the design to the set of tasks and decompose the tasks into smaller tasks because the next step is to estimate the time it will take to write each of the smaller tasks. If any task is longer than 1 day, 8 hours, you can maybe go to 16, but usually not any more than that. You break the task up into subtasks, and you estimate each one of them. You pick the list of high-priority tasks that fit into one iteration cycle. Since you now know you have an estimate of how long it's going to take you to do each task, and then you have a prioritized list of tasks, you can just add them up until you get to the number of hours in the iteration, and that's where you stop. And then you write and test the code for all the tasks for the current iteration. You release the current iteration to the customer, who should run acceptance tests on it. The team doesn't typically write the acceptance tests, the customer does. And then you add any bugs that the customer found to the list of current tasks, because that's work you're going to have to do later on. You're going to have to fix things. And then when you've finished all the planned iterations, or you've reached the deadline, then you release the product. Because remember, at the end of every iteration, you have code that works. So, question. And we'll talk about this in class. What kind of projects would an Agile development process work for? You can think about that, and we'll talk about this in class. And that's all I want to talk about for now. This is sort of general Agile stuff. Talk to you later.